Hello students, chapter number 1 electric charge and electric field. Today we are going to discuss the applications of Gauss law. In the previous lecture we have discussed two theory. One is electric flux and second one is Gauss law. So if you are knowing that two theory as well as that equation phi equal to vector E dot vector A and phi equal to surface integral E dot dA equal to Q inside upon epsilon naught. So in this lecture definitely you will get the completely idea. Now what is the importance of today's theory? So in the NCERT as well as Gujarat board, this same theory whatever we have discussed today, that is already asked in 4 marks. So this is very important question for examination point of view as well as competitive exam point of view. So application of Gauss law, very important topic. In that we are discussing only first application of Gauss law. With the help of this Gauss law we can derive the electric field equation very short way. Okay, so what is the first question? Electric field due to an infinitely long straight uniformly charged wire. So हमने earlier in the previous lecture we have discussed the linear charge distribution because wire is one dimensional object. Okay, so from the given data, if we draw a wire which is uniformly positively charged wire, and if we are selecting different points separated at a distance r, that is p, q and r, so on, so that p, q points are the same distance from the center of the wire. So if we imagine a boundary like cylindrical Gaussian surface to enclose the charge. So if we draw one cylinder and what we call the name cylindrical Gaussian surface, this one is cylindrical Gaussian surface. You have to write in the full form, cylindrical Gaussian surface. This Gaussian surface according to the Gauss theorem, and the shape of this surface is cylinder. So cylindrical Gaussian surface which having length L and radius is r. Now you knowing the important points regarding the Gauss law, what we have discussed in that one, the charge is enclosed by the closed surface, that's why we are selecting this surface is cylindrical Gaussian surface. So what is linear charge density of this given wire? Linear charge density, that is nothing but lambda equal to charge per unit length, so Q upon L, where L is the length of length of cylinder. Now if you look at this bottle, this is exactly shape of cylinder. So this surface 1, surface 2, 1 and 2 surface are circular, and this is third surface which is curved surface. So if we mention that 3 surface in the given figure, this surface 1, 2 and this one is 3. Okay, now we have to calculate the flux regarding these 3 surfaces. So we want to find the electric field at given point P situated at a perpendicular distance r from the linear charge distribution of the wire. So what is my next target? To calculate electric flux linked with the 1, 2 and 3 surface. Okay, and finally we can add. So what is the formula of flux, that you know, because in the previous lecture we have discussed. So what we have to calculate? Electric flux for surface 1. So surface integration E dA cos theta, that is missing. So what is theta? Angle between vector E and vector dA. So we have to specify what is the direction of E and dA at these 3 places. So from the charge distribution, this is linearly charge distribution positive, so radially outward electric field. ऐसे भी यहाँ पे radially outward electric field, so this is the direction of E. Same way over here, if we take a small portion, so what is electric field? Radially outward. Now area vector, if you know, in the electric flux lecture we are discussing the how to calculate area vector. So this surface 1, surface 2, from the surface 1 this is the area vector dA perpendicular to this surface. Similar way over here, and for the third case this is over here. So all the area vector in each case are perpendicular to the given surface and radially outward. So how we can draw over here this is dA, area vector. What is angle between that two? 90. Same way over here area vector 90. ये सर्कल है, ये भी सर्कल है और ये कर्व सरफेस है, सो यहाँ पे एरिया वेक्टर आएगा dA. ये देख सकते हो 1 और 2 में एंगल 90 है, सो कैलकुलेशन सेम रहेगा. और थर्ड सरफेस में कर्व सरफेस जो हमने एज्यूम किए वहां पे एंगल 0 आएगा. सो बाय पुटिंग दैट थ्री वैल्यू हियर 90 cos 90 is 0, you know, so flux link with the first surface is 0. Again for second surface, from the diagram this is cos 90 0, so flux link with that two surface is 0. Now for third one the angle between that two is 0, so cos 0 is 1, that you know. And look at this, separation is r, so different points p, q, r, whatever the points we are assuming, at that point the electric field is uniform. So E is constant, take outside. What is my answer? Integral dA, cos 0 is 1. So integral dA, recall your fundamental of 9th standard. What is the surface area of cylinder? 2 pi RL, where L is the length of cylinder. So by putting that two value, what is this answer? Integral dA is 2 pi RL, surface area of cylinder. Now give the equation number. This is one equation. So by adding the total flux we get phi1 plus phi2 plus phi3, 0 plus 0 plus 2 pi RL into E, which is equal to 2 pi RL into E. Give it number 2. Give it number 2. From the Gauss law, what is Gauss statement? Phi equal to Q inside upon epsilon naught, where Q inside is charge enclosed by this cylindrical Gaussian surface. So what is that from equation 1? Lambda into L. So from equation 1 and 2, by putting the value of Q inside as well as Q, total flux. So what is total flux? 2 pi RLE is equal to Q inside from the equation 1, lambda into L upon epsilon naught. L cancel out. Okay, L cancel out. So what is my answer? E equal to lambda upon 2 pi epsilon 0, in this way you write, into 1 upon r. This is equal to this scalar form. Now we want to write this one is in vector form. So what is the last equation of this theory? That is vector E equal to lambda upon 2 pi epsilon 0 into 1 upon r into r cap. What is the meaning of this r cap? What is the meaning of this r cap? So look at this diagram. What is the direction of electric field? Is radially outward, and that is in the direction of radius. So that's why r cap is what is the indicate the direction of electric field is in the direction of radius. Okay, so this magnitude and this one is direction. Now you have to remember this equation for calculation purpose. And for extra important point regarding this theory is graph that you may ask in JEE NEET or any other competitive exam. We have to draw the graph of E versus R. So look at this parameter is constant. The lambda for a given data is constant because charge per unit length, that for given data is constant, and denominator all the three terms are constant. So what we can say, E into R equal to constant. So आपको पता है Boyle's law, PV equal to constant, P is proportional to 1 upon V. What should be the graph of that Boyle's law? Hyperbola, rectangular hyperbola, because one physical quantity is increased, so remaining one is decreased. So in this way this is a curve which indicate E is proportional to 1 upon R. This is extra information for your competitive exam point of view. Now further we simplified one NCERT textbook numerical, that is exercise 1.23. What is in the data they have given? For uniformly charged conducting wire, the electric field is given, that is 9 into 10 raised to 4 Newton per coulomb, and the radius of given cylinder is 2 centimeter. Then we have to calculate the linear charge density regarding this question. So we may have these two data and we are knowing the constant epsilon 0. What is the unit of epsilon 0? In SI. So always you remember when we have to convert, whenever we are dealing with the constant, so we have to see the unit of constant. So what is the unit of epsilon 0? That you know in SI system. Okay, so this one is in SI, so we need to convert centimeter into meter to get the final answer. So what is the formula? Already we learned in this lecture, E equal to lambda upon 2 pi epsilon 0 r. Make the subject lambda, so product of these two terms. By putting the values you will get this answer, 10 microcoulomb per meter, where you remember this is not unit coulomb per meter, microcoulomb, micro means you know 10 raised to minus 6. So in this way you understand this complete idea about these applications of Gauss law, first application. और नेक्स्ट वीडियो में हम डिस्कस करने वाले हैं सेकेंड एप्लीकेशन ऑफ गॉस लॉ. सो उसके लिए आप इस चैनल को शेयर एंड सब्सक्राइब कीजिए और बेल आइकन को प्रेस कीजिए ताकि नए वीडियो की अपडेट आपको जल्दी मिल जाए.